Hi everyone. Today I explain how AI chatbots work under the hood. In modern AI, meaning itself becomes numbers. These models don't store facts or feelings the way humans do. They learn patterns to decide what comes next. That simple idea powers today's AI chatbots like ChatGPT, Gemini, or Claude. In this video, I want to show you how probability became language and how language became intelligence. To explain language models like I would explain a car, not how to build one in a factory, but how the finished machine works. We'll focus on the trained model. What its key parts do, like an engine or gearbox in a car, and how they work together. What happens from your prompt to the final output? Training is a process of tuning millions of knobs using huge amounts of text until the model becomes really good in predicting the next token. When people say chatbot today, they are not talking about FAQ anymore. An LLM is a type of AI trained on a massive amount of text, books, articles, websites. It doesn't memorize. Instead, it learns how language works, how words connect, how meaning shift with context. A modern chatbot is mostly just the front panel, the chat window you type into. The LLM underneath is an engine. It takes your input, interprets it, and generates the response, token by token. That's why chatbots are now everywhere. They generate language dynamically. If you want to truly understand modern chatbots, you first have to understand LLMs, because they are the core technology that makes intelligent conversation possible. To understand how large language models work, let's start with the original inspiration, your brain. Inside your head are billions of neurons. Each one is tiny, simple, almost dumb on its own. A neuron receives signals, makes a small decision, and passes a signal forward. Intelligence emerges from teamwork and massive scale. Artificial neuron networks borrow that exact idea. They are built from simple mathematical neurons, connected in layers. Each one does a simple calculation, nothing impressive. But stack in millions or billions of them together, and suddenly the network can detect patterns, handle language, and even generate new text that feels human. Neural networks didn't just improve, they scaled. You feed them examples, and the model learns the structure on its own. That's why neural networks won the race, because they copy the brain perfectly. They don't, but because they copied brain's strategy, learn from experience, and get better. Let's see what a neural network is actually doing. Single artificial neuron is ridiculously simple. It takes a set of numbers, mixes them, and outputs a new number. By itself, it's not smart at all. The power comes from layers. Those neurons are stacked into many layers. The first layer doesn't see words the way humans do. It sees tokens, small chunks of text converted into numbers. Then the network starts refining those signals layer by layer. Early layers notice simple patterns and relationships. Later layers connect patterns across the sentence. Deeper layers build higher level meaning. Each layer is like a slightly smarter filter than the one before it. It's almost like the model keeps asking better questions. What pattern is this? What does this token means here? What does the user probably want? No single layer sees the whole picture. Understanding emerges because many layers cooperate, each doing one tiny job. On the next slide, I will show you the bigger ecosystem. Transformer models convert voice to text, generate text, create images from text, and some even generate sound. You will see a key rule. What you train on shapes what you can produce. Different inputs, different outputs. And here's the thing most people miss. How you start the conversation matters. Before the model answers, it's guided by two instructions. First, the system prompt. That's the operating mode. It defines the role and boundaries, basically telling the AI who you are, what you are allowed to do, then the user prompt. That's your actual question or task. So if you want better results, don't only ask better questions. Start with better context. Your input, plain text or text plus image, enters a stage called embedding. Embedding is basically translation, not between human languages, but from human language into math. The sentence is chopped into small pieces called tokens. Sometimes a token is a whole word, sometimes it's part of a word, sometimes it's punctuation. Then each token gets converted into a vector, a long list of numbers. In GPT-3 class models, that vector can be over 12,000 numbers long, 12,000 dimensions for a single token. Imagine a simple dot turned into a huge list of numbers. No single number in a vector means anything. Meaning doesn't live in one coordinate. Meaning emerges from the relationships across entire vector, across all those dimensions at once. Think of audio. One frequency alone is just a thousands of combination becomes music. Same idea here. And here is the important part. Humans didn't hand design this meaning map. The model learns it from a massive amount of data. It discovers a geometry where related ideas end up near each other. That's also why it can be multilingual. Take the word unbelievable. The model doesn't see one solid block. It sees the pieces like unbelievable. Reusable building blocks, shared patterns, same math space, different languages. And once your text becomes vectors, that's when the model can finally start doing what it does best, turning numbers into meaning. Here's the sailing analogy. Imagine a living harbor. Every boat starts at the same place, but each one set a different bearing, different course. Words like mom and mama sail in almost the same direction. They stay close together. And a word with a completely different meaning sets a very different course and quickly ends up far away. Distance here doesn't mean kilometers. It means difference in meaning. This is how the model navigates language, from tokens to vectors to relationships, and finally to meaning. Now, we are entering the attention layer, the secret sauce behind why modern AI feels context aware. Because words don't carry meaning in isolation. Take fox. It can be an animal or describe a person who is clever and sly. And apple could be a fruit or a trillion-dollar company. So, how does the model choose the right meaning? When it reads a word, it quickly looks around the sentence and asks, which other words should I pay attention to understand this one? When the model sees a noun, it often checks nearby descriptions, adjectives, and related words. The same token can end up meaning different things in different sentences because its neighbors are different. And this part's 2048 context size. That's simply how much the model can read at once. More context means better memory, or what came earlier. Extra details, earlier sentences, and fewer misunderstandings. Alright, let's zoom out and see the whole machine. People say LLM or transformer. For this video, treat them as the same thing. A powerful text engine with a very clear pipeline. Everything we covered happens in this loop. First, embedding turns words into numbers. Your text stops being letters and becomes vectors. Numbers, that's why similar words like mom and mama end up close together. Second, attention. Shine the spotlight. This is how the model becomes context aware. It asks which other words in the sentence matter most right now. That's how it decides whether apple is a fruit or a company. Attention adjusts the vectors so the meaning fits the sentence. 3. MLP, multi-layer perceptron. The model takes those context-dated vectors and refines them. It strengthens useful patterns, filters out noise, and combines signals, basically prepping the information so a prediction becomes possible. What connects all of this? The weights. Those are the model's stored knowledge. Like millions or billions of tiny knobs during training, those knobs get tuned until the model reliably learns language patterns. In our case, the model is already pre-trained, so those settings are already locked in. We will cover how training tunes them in a separate clip. And number 4, output. Guess the next token. Finally, the output layer makes a prediction what comes next. The next token, the next word. Numbers go forward through the transformer, and each stage, the model reshapes them using what it learned during the training until it can produce the next token. Now, the model has to do something with what it found. That's where the MLP comes in, the multi-layer perceptron. This is where the model takes the highlighted meaning and refines it. Within the whole context window, in GPT-3, it's up to 2048 tokens. The model runs every token through the MLP, no one by one, like reading a book, more like sending items to the same machine at once. Think of it like a super fast filter. It asks million tiny mathematical questions like, does this look like a person? Is this a place? Is this a product? Does this pattern match something I've seen before? Each match gives the factor a small push. Some features get boosted, other get turned down. If attention suggests that Apple is being used like a tech company, MLB strengthens the company, weakens the fruit signals. Attention finds the right clues. The MLP sharpens them into a clear meaning, predicting what comes next. Now we are at the finish line of each step, the output layer. This is the moment the model stops thinking in numbers and turns that into actual next word. Inside the transformer, the model has a final internal summary of everything you have typed so far. The output layer takes that summary and asks one big question. Out of all possible next tokens, which one fits best? Imagine a giant scoreboard. One slot for every possible next token. Each token gets a score, more likely or less likely. Then the scores are turned into probabilities, and the model chooses the next token. Example, if that sentence is, the most famous sea catastrophe in history is, the model will strongly prefer something like sinking and give almost zero chance to singing. So the output layer doesn't create meaning. It uses the meaning the model already built to pick next piece of text. Once the token is chosen, it gets added to your prompt, and the whole loop runs again. Embed, attention, MLP, output, next token. Repeat that loop, and you get a sentence. Repeat the sentences, and you get paragraph. And that's the core magic. Full document is generated based on token at a time. Each step guided by probabilities. Let's take a deep dive into the output layer. The moment the model turns its internal understanding into an actual next word. Step 1. The model grabs its final hidden state vector, the model's current thought. Step 2. That vector goes through the unembedding matrix. Picture this like a learned translation table. The model built during the training, connecting internal meaning back to the real language. What comes out? A long list of scores called logits. Basically, one score for every possible next token. That can be over 50,000 options. Important, logits are not probabilities yet. They are more like confidence scores. Higher score means this token fits the context better. Step 3. Softmax. Softmax turns that messy scoreboard into the clean set of probabilities. Numbers between 0 and 1. Now, the model can pick the next token, either the most likely one, or it can sample from the top choices for more variety. And then the loop continues. Next token, next step, next word. Softmax is a model's translator from scores to chances. The model first produces logits, raw scores for every possible next token. More than 50,000 of them. But scores aren't probabilities. Softmax turns that messy scoreboard into the clean result. Every option gets a probability between 0 and 1, and all probabilities add up to 1. Here's the intuition. Softmax rewards the leaders. A token that's slightly ahead becomes much more likely, and the weak options fade into the background. So, after Softmax, the model has a real odds list, and it can pick the next token, the top one, or sample from the best few. Here's the full story. The chatbot is just the smiley face and text box. The real brain is the LLM underneath. Your words get translated into numbers. Attention shines a spotlight on what matters, and MLP polishes the meaning. And the output layer spins out probabilities and picks the next token. Then it does it again and again, one token at a time. So it's not thinking like a human. It's more like a super fast autocomplete with PhD and zero sleep. Give it a good context, and it will sound brilliant. Give it chaos, and it will confidently invent nonsense. Thank you very much for listening. See you next time.